In this video, I will go over how to calibrate the densitometer and make liquid density measurements. The densitometer that we have is a Metapar DMA45 densitometer that uses a glass oscillator to measure directly the vibrational period and uses a calibration constant to relate to indirectly the density of the liquid. Briefly, to measure the density of the liquid, we inject the liquid into the glass oscillator that is like a U-tube all the way around. And then it will indirectly give us the density measurement over the panel. The formula for the calibration constants A and B are given by the manufacturer, where the calibration constant A relates the period tau of water and air and the density rho of water and air. And the calibration constant B uses the calibration constant A and the density and period of the air. The period is something that we can measure, but the density is what we also want. But here the density is a standard density that is based on theory, so we can get the water density using some correlations and the air density also with some correlations that relates the dry air and water. So the air density here is wet air density. The standard densities are highly dependent on temperature, and for air density it also depends on the pressure, partial pressure of air and water. The R here is the ideal gas constant in mass basis. To get the partial pressures, for water we can relate the saturation pressure of water with the relative humidity of the system, and then we can calculate the saturation pressure using Anton's equation. For the dry air's partial pressure, because we assume the system only have air and water, then we can subtract the total pressure with the partial pressure of water to get the dry air's partial pressure. Calibration constants can be adjusted using the top panel of the densitometer. On the calibration panel, there is a screw that indicates the mode that the densitometer is currently in. Notice that we must use the black mark that indicates the location of the mode. For example, currently it is in the density mode. This thing here is for screwdriver, and its direction does not indicate the mode, so it is the line that is perpendicular to the screwdriver's line. So currently it is in densitometer, the density mode. We want to use a screwdriver to switch the densitometer to the period mode T. We want to change the line from rho to T. Now we're in the period mode. We can then turn on the densitometer using the power button and then turn on the light. There are two segments. Make sure to turn all the way up to turn on the light. Then we can record the period of air when the value stabilizes. In this case, it is 4.6205 with the unit of seconds. We then want to measure the period of water. Use a plastic syringe to draw at least 1 milliliter of deionized water. After drawing it, we will see that there will be some air bubbles. We want to remove all the air bubbles from the syringe carefully. Remember to wear safety glasses and do not splash the liquid into your eyes. Then we want to inject the deionized water into the U-tube using the plastic syringe. Make sure to avoid air bubbles. We want to inject fully so that you can see some water coming out of the top of the U-tube. Then leave the syringe on the side. You can see from another angle where the water is injected from the bottom and the water will flow to the top. Make sure to get the air bubble out. It's okay to spill a little water out of the top pore. And then make sure to leave the syringe on the side so that the water doesn't come out at the end. Then record the period of water when the value stabilizes or after 2 minutes. The value here reads 6.1137 seconds. In the provided Excel sheet, using previously discussed theory, we can enter the period of water, which is 6.1137, and the period of air, which is 4.6205. Then the Excel sheet will calculate for us the calibration constants A and B. We want to record A and B so that we can enter it into the densitometer. Now we can change the calibration constant on the densitometer using the calculated values of A and B. Using a screwdriver, we can change the value by screwing it left or right. And after changing the values of A and B according to the spreadsheet, we can then use the screwdriver to switch the densitometer to density mode to verify our calibration. Remember, we still have water in the U-tube, so now it will display the density of the water, and it should match the literature value of around 0.998. We can then draw out the water and remove the syringe. Now in the U-tube, it is left with air and some water that is attached to the U-tube. In order to dry the U-tube, we want to turn on the pump. We will first put in the catheter into one of the pores. Then we will turn on the pump, and then it will start drying. We want to read the density measurement of the air and compare to the literature after the U-tube has been dried. Then we can turn off the pump. To measure the density of samples of interest, basically we follow the same procedure of getting samples into the densitometer when doing calibration. We will draw all the samples, avoid air bubbles, and inject them into the U-tube. Then we will record the density measurement when the value stabilizes. And finally, we will draw out the samples and rinse the U-tube with acetone, so this avoids cross-contamination. And we will turn on the pump and put the air line into the U-tube until the U-tube is dry for the other samples. And make sure that you rinse the syringe between use so that you also avoid cross-contamination in this step. When we're ready to shut down the densitometer, we want to make sure that the U-tube is dry. So first dry the U-tube, turn off the pump, then turn off the light, finally turn off the densitometer. Place back the calibration panel's lid, screwdriver, and the syringe so that the next user can use the densitometer with ease. In this video, I went over the theory for calibrating a densitometer that correlates the vibration density of liquid with its density. I also went over the practical procedure for using a densitometer to measure the density of liquid of interest.